Hello guys, welcome to Learn Extra Love. Grade 12s, it's finally your turn. Today we're doing life science with Aslam. Guys, I'm so happy to be here. So happy to see you, Aslam. How are you?
What shall I call you? Shall I call you a mutant name or your normal name?
Let's call me my normal name.
Normal name. How are you doing?
Great, thanks.
Great to have you back.
Great to be here, actually. What are we doing today, Aslam?
We're doing some interesting stuff. We're looking at the endocrine system.
Okay.
And we're talking about hormones.
Awesome.
And what they do to
stuff,
you.
Eh? That's awesome stuff. So you guys heard that, a very, very important section. So I hope that you guys are watching, and I hope even more that you guys are going to be watching until 7:30. Yes, you heard me right. Today's show will be extended between 7 and 7:30. We are going to have the After Earth special, guys. Did you guys hear correctly? This is not just for you grade 12s. Of course, you grade 12s by default you're here, but this is also for grade 10s and 11s and your brothers and your sisters and your donkeys and your chickens, everything and everyone that wants to listen up. You better join us between 7 and 7:30. We will be going through some After Earth lesson plans to show you how the movie, I hope it's making sense now, or it will make sense then at 7, of course, that the movie actually links to some awesome stuff that you will be learning during the show today. So for you guys right now, to find out more information, you need to go onto Life After Earth science.co.za. I will be posting it up on Facebook for you guys to check it out. Also, more importantly, or maybe not more importantly, but also we are going to be having a live stream, guys, to a Macmillan launch for their digital ebook, guys. This is going to be live. We're going to be chatting to the awesome folks over at Mindset. Thank you guys for sponsoring our awesome show today, but I can't wait to chat to you guys at between 7 and 7:30, of course. So guys, make sure that you join us. For now, jump onto the Facebook page, see everything that's been going on. It's been such an awesome afternoon and into the evening. I'm glad that you guys are here, and you will log on to Facebook, facebook.com/learnextra, and Twitter to find out more about this lesson on the endocrine system, as well as the After Earth stuff, guys. So jump on there right now. Okay, also check out your notes. They're already up. So enjoy your show. Over to you, Aslam.
Katlecho, you said a lot there.
I know I said a lot, eh?
You know what? Just listening to what we have to do makes me tired. Good. We never tired, yeah. We
never tired.
We never tired. We're full of energy. If not, we'll get some Red Bull. Okay, guys, we are there with endocrine system. Let's move on. We've got a long way to go today. We've got lots of things to do. First up, though, is what we're doing now, and that's from now till 7 o'clock. We are going to concentrate on the endocrine system and questions and answers related to that. And later, we'll talk about the other stuff. What do we do here? First of all, we look at the characteristics of hormones. And guys, if you've been following our program as we've been going along, you'd know that we have touched on the characteristics of hormones when we discussed plant, and I say it in inverted commas, plant, in inverted commas, hormones. Okay, so we've spoken about it, but we're not going to take it for granted that you know it already. We're going to come back to it again. Explain the differences between the endocrine and exocrine glands. What are the differences between those two things? Then we look at the location and the functions of hormones produced by the following endocrine glands in the body. Hypothalamus, and we look at ADH. We look at the pituitary gland, growth hormone, TSH, FSH, LH, prolactin. And notice I'm going through the names quickly because we're going to look at them again. Thyroid glands and thyroxine, adrenal glands, adrenaline and aldosterone, the pancreatic islets of Langerhans, or the islets of Langerhans of the pancreas. We look at these two main guys, insulin and glucagon. Then we go into the ovary. That's not a nice thing to say, go into the ovary, but nonetheless, we look at the ovary. That also won't come out right.
Yes,
okay. So examine, that also won't be right. There's not many verbs that we can use in ovary. Nonetheless, we study the hormones that are secreted by the ovary, and they are estrogen and progesterone. And then we move on to the testes, and we look at the effects of testosterone in the human male, okay? So those are the things we're looking. Then we further go. We look at all of these glands and we look at how they work, their hormones they secrete, and the functions of the hormones. Then we want to know, how do these hormones interact with each other? How do they control each other? And that's when this principle of negative feedback mechanism comes in. Although in this lesson, we use TSH and thyroxine as an example, remember in the examination, you can get any example. They can ask you to explain any example. Most of the endocrine glands secrete hormones that operate on the negative feedback mechanism. We can talk about ADH and water. We can talk about glucose and sugar. We can talk about glucagon and sugar. We can go on with all the hormones, estrogen and progesterone and FSH. We can look at that as well as a negative feedback mechanism. So you must be able to understand the principle and apply this principle to all the other hormones that we look at. Keep that in mind. Lastly, we also look at the causes, prevention, symptoms, and management of each of the following: diabetes, thyroid disorders, and growth disorders. Obviously, when we look at these disorders, we are looking at those disorders in terms of the endocrine system, not other disorders that cause some of these things. We're only talking about these disorders in terms of what we are studying. And what is that? The endocrine system. Good. Let's get right into it. As we've been accustomed, we mix and match. We put the questions in and the content in at the same time. First question, because we've looked at this before, is what is a hormone? What is a hormone? Simply put, a hormone is a chemical messenger. To be more correct, we would say it's an organic chemical messenger. It's organic, that means it has carbon, hydrogen, and oxygen. It has carbon, hydrogen, and oxygen. So it is organic, and it's a messenger. It's chemical, obviously, and it's a messenger. Messenger meaning it takes messages from one spot to another spot. Now then, what are the characteristics of hormones? First of all, by the definition, they are organic. It's a characteristic that they are organic and that they are chemical and that they are messengers. That's one of the primary characteristics of hormones. Secondly, going on with that organic, most of them are protein. Most of them are protein. Some may be steroids, some may be polypeptides, and some may be amino acids. Going further still, they work in an integrated system. In other words, they don't work on their own. They work as part of a team, an integrated system. This is very important, and this is where we differ. When I said earlier, we said that we put that in inverted commas in plant hormones in inverted commas. And let's see, why do I say that? Generally, true hormones are secreted in one area, and they work in another area. That's why I think it's okay. You.
No,
I
not me. I'm sitting
I haven't
here
made these
quietly.
tongue slips before. I think you have an effect on me.
No,
What's
I
that
don't think
perfume
so.
you're wearing?
I don't know. It's a secret.
It's called, it's a secret. There we go, poison. Secret
No.
poison. Okay, good. So secreted in one area and work, not work in another area, which we call the target organ. All right? Now, let's go back. Let's step back to plant growth substances, as I prefer to call them. Why do we say that they are not true hormones? Because those substances, they were secreted in the same area in which they worked. So we say they're not true hormones. Good? Then we move on, we say they have specific effects, which are generally long-term. The hormone is not secreted now and it happens same time, something's going to happen immediately. Apart from some of them, like insulin and so on, but still, it's not going to happen instantaneously. It will take some time. If you were watching the grade 11 last week, you would have seen Llewellyn having condensed milk, and his level of sugar went rocket high, and after some time, we see that insulin kicks in and the sugar level starts coming down. It didn't happen immediately. It happened after some time. So generally, long-term. Also very important about hormones, they are transported in the blood. In humans, in animals, the hormones are transported in the blood. This is very key, and we'll understand that later when we compare the two systems. Next question says, distinguish between, one of our objectives was to know the difference between an endocrine gland and an exocrine gland and provide an example of each. And back to there. That will always bug me. Okay, good. Endocrine glands secrete their hormones directly into the blood. There's no tube, there's no duct. It goes from the gland directly into the blood, and the blood then takes this hormone, this messenger, to where it must act. For example, the pancreas secretes insulin. This insulin is secreted into the blood. From the blood, it goes to the liver, where it will do what it's supposed to do. We'll get into that detail a little later. And so too with other endocrine glands. Whereas exocrine glands, let's just underline those keywords again, secrete their hormones directly into the bloodstream. Whereas exocrine glands secrete their hormones, this should be their chemicals. The chemicals that they secrete, it's not hormones, because hormones come from endocrine system, remember that. So the exocrine glands secrete their chemicals, the substance, whatever substance they're secreting, into a duct which transports the substance to where it is needed. Example they're given, there's examples given there. Endocrine, the pituitary gland, the thyroid gland, any other suitable example you can give. Exocrine gland would be the salivary glands. The salivary glands secrete saliva, which go into the salivary ducts, and from there they empty out into the mouth, not via the blood. They go into a duct, a tube, that brings the saliva to the mouth. The sweat glands, same thing. If you know the structure of the skin, which we're going to touch on soon, you'll find that you have sweat glands. The sweat glands secrete sweat. The sweat goes into a sweat duct, and from there, the sweat then comes to the surface of your body, from where it may evaporate to cool the body. So those are the differences between endocrine and exocrine glands. And remember in the exam, guys, the questions won't come just the way we put them here. These questions were put deliberately. Most of them are level 1 questions. Why? Because we want to learn the work. When you want to learn the work, we're going to ask describe, list, explain the differences. So level 1, cognitive level 1. We're not asking you to go beyond what you have learned already. You're simply explaining or defining one, and you're defining the other one. Definition of endocrine, definition of exocrine, and you're providing from recall, from your memory, the examples. But they don't come that way in exam, remember that. We will look at some other examples later. Now, then, we then move directly into this endocrine system that we are talking so much about. And what better way than to look at the diagram first? And there we have the diagram of the body. Now, just a tip for you when you're learning this system as well. Take a clean double sheet of paper. Draw this pencil line of the body. Remember, we're not asking you to be an artist. We need a reasonable representation of these glands. And draw the glands in terms of where they are in the body. So you are learning the location of the glands. And draw a reasonable representation, so you're learning the structure of the gland as well. Then you will label the glands, obviously. On this double sheet, you make sure that you spread out the labels. There's not many. 1, 2, 3, 4, 5, 6. 6 labels that you need to know. You label those things, and you spread them out onto your sheet of paper, and next to the label, use another color of pen and write down the hormones that are coming out from that particular gland. And yet, in another color, write down the function of those hormones, next to the hormone, obviously. So in other words, in your mind, you're getting the differentiation between the name of the gland, level 1, the hormone it secretes, still level 1, the function of those hormones, level 2. And if you want to, you can still use another color of pen to talk about disorders to those that we have to know about. So you got 3 or 4 levels of one chapter on one double page of paper instead of reading the whole chapter, you have one page which got everything on that chapter on it, apart from negative feedback mechanism and so on. Let's label these things quickly. Right on the top, we have the pituitary gland. Coming down, saddling or the larynx is the thyroid gland. On top of each kidney, one each, we have the adrenal glands. Slightly lower, between the kidney, behind there, we have the pancreas, in front of the kidneys, the pancreas. And in the pancreas, we have the islets of Langerhans. Don't worry about the names, we're coming to them again just now. And then in females, we have the ovary. And in males, we have the testes. Each of these glands will secrete hormones, which we are going to navigate when we come back from the break.
Of course. So guys, there you go. You have a little bit of a break to stretch and do whatever you need to. But guys, please keep your eyes glued to the TV screen, because the After Earth clip will be playing during the break. And then when we come back from the break, I will be telling you all about it. So stay tuned. Watch the After Earth awesome clip. Think about me while you're watching, because I really do love that clip. And then I'll tell you more about it straight after the break. See you just now. Welcome back, Mindsetters. I really do hope you enjoyed that clip, because I certainly always enjoy it every time I watch it. I'm so excited to see the film, just to know how, like, the impact that we have on our earth, guys. It's so important that we look after this earth. There is only one. Of course, if you enter the competition that we have now on Learn Extra Live, you can stand a chance to win double tickets to see After Earth, guys. I mean, the entire movie. So you'll be able to check out the clip within the whole movie at the movie theater with a friend or whoever you choose to go with. And of course, you need to enter before you actually win, guys. Remember, I think that's an important part, right? And as you guys know, to enter the competition, you need to log on to www.learnextra.co.za/After Earth. And you need a secret code to enter it. The code for today is action. Action. So you guys need to jump onto that website, www.learnextralive.co.za, and then /After Earth, and then you type in action, and you can stand a chance to win 2 tickets to see that show. Guys, I will be announcing the winner at the end of this show, so please keep your eyes peeled for that. It might be you. And of course, join us today till 7:30 for an extra little bit of a special After Earth time that you guys can share with us. Call every single family member you have so that they are there from 7 to 7:30. Okay, over to you, Aslam.
Katleho, thank you so much. Guys, what we were talking about before the break, we looked at the diagram of the body to show the location of the different glands. And I was telling you before we left what we need to do on a double sheet of paper. So let's just look at one example. I'm not going to do all here. Let's take the pituitary gland. There's there. You don't have to, if you want to, you can draw that there as well. But important is to write pituitary gland. That's a label. And then I said use another color to write down the names of the hormones that are secreted by the pituitary gland. For example, growth hormone, STH is the other name for growth hormone, or TSH. Don't confuse those two, TSH, etc., etc., etc. And then you use another color of pen. Let's try the orange. Next to growth hormone, you will write, you'll have space for it, obviously, growth and development, normal growth and development. And next to TSH, you'll say stimulates the thyroid gland to secrete thyroxine. You get the idea. The idea is name of gland, hormone secreted, and finally the functions of those hormones. And you want to add another level. You'll say if something goes wrong with those hormones, too much, too little, you can add that as well. So on one double page, you have your whole chapter on this. I'm not going to dwell too long on that. Let's move on. The first gland that we came across in the body was the pituitary gland, and obviously the hypothalamus, which we didn't label on that diagram. But the hypothalamus is part of the brain. We've looked at that before. Remember, many of the hormones come from the hypothalamus, and they then go to the pituitary gland, from where they are then released. We are not interested in many of them. We are interested in one of them. And the one we are interested in is ADH. The other one we'll also talk about later is oxytocin. So the ADH comes from the hypothalamus and then comes into the pituitary gland. And then the pituitary gland will then release when necessary. But let's look at what the pituitary gland does overall. We find that the ADH is released from the pituitary gland, and ADH works on the kidney. The function of ADH is to control the water balance in the body, osmoregulation. Okay? When there's too much of water in the body, there will be less ADH secreted, so that this is grade 11 work coming back in grade 12, so that the collecting tubules and the distal convoluted tubules become less permeable to water, and therefore you'll reabsorb less water, then your urine will be dilute. That means there'll be more water in your urine. That's the story about ADH. And if there's a shortage of water in your body, on a hot day, you're sweating, you're exercising, whatever it is, and you're losing a lot of water, more ADH is secreted. If more ADH is secreted, then the tubules become more permeable to water, and more water will be reabsorbed. And therefore, in that way, we're taking back water from the tubules. Therefore, there'll be less water in your urine. Your urine is said to be concentrated. That means there are more solutes in the urine than there is water. You'll notice in these times, in these two different scenarios that I gave you, the urine, when it's dilute, would take a lighter color, and when it is concentrated, takes a darker color. More transparent when dilute, and more yellowy, deep yellow when it is concentrated. The pituitary gland also releases oxytocin, which has two major functions. One is it helps to release milk, and also it starts the onset of labor in reproduction. But oxytocin is one of the reproduction hormones, which we will learn much more about when we do reproduction. For now, oxytocin is released by the pituitary gland, and it stimulates the breast to release milk, and it stimulates the muscles of the abdomen and the uterine wall to contract and relax faster during labor, when the baby needs to be released from the body. We also have from the anterior pituitary, the growth hormone, which works on bones and soft tissue, which will cause our normal growth and development. That means increase in length of these structures so that we grow. Okay. Also, we have the ACTH, which will stimulate the adrenal gland to secrete adrenaline. We have TSH, thyroid stimulating hormone, and thyroid stimulating hormone will stimulate the thyroid gland to secrete what it's supposed to secrete, which we're going to come to just now. Then we also have FSH and LH, also called ICSH in the male. Instead of being called LH in the male, it's called ICSH, interstitial cell stimulating hormone. Again, more about that in reproduction. Suffice to say that FSH and ICSH, they stimulate the testes and the ovaries to do what they're supposed to do, which we'll talk about later. Also, we have the FSH and LH in the female now. The FSH stimulates the development of the follicle, LH stimulates ovulation. We also have prolactin coming from the anterior pituitary, also works on the breast, stimulates the development or the development of the mammary glands, which will produce milk. Mammary gland is the gland that is found in the breast, not M-E-M-O-R-Y, Katlejo, M-A-M-M-A-R-Y. Huh?
Oh, okay.
I always ask this question in class. I say, where's the mammary gland? And all the kids point to the head. Okay, okay. They seem to have forgotten, the memory not working. All right. Okay, good. So we have those hormones from the pituitary gland. Remember, you need to know the name of the hormone and what it does. You move to the next one, next gland. The next gland is the thyroid gland. I told you earlier, straddled on the larynx, just on top of the larynx. There's one left and right side of the thyroid glands there. Okay. What does the thyroid gland secrete? It secretes thyroxine. What does thyroxine do? It controls and regulates your metabolic rate. That means the rate at which you burn food, respire. It affects growth and development. Can you see that it works in conjunction with growth hormone from the pituitary? This thyroid gland secretes thyroxine, which also affects growth and development. It also affects functioning of the heart and nervous system. These are the three functions of thyroxine. Good. We then move on, lower down on the kidney, on top of each kidney, mass of tissue, the adrenal gland secretes adrenaline. What does adrenaline do? Now, guys, Katlecho and the rest of your friends and those that are younger than you, which child, which teenager, which varsity student can you talk about without saying that they know about adrenaline is pumping?
I think most varsity ones do, hey?
Well, no, isn't it?
Yeah.
They're talking about it all the time.
Yeah.
You have a conversation, my adrenaline is pumping. Right? And when our adrenaline is pumping, what happens to us? What do we mean by that? We simply mean that we're excited. Huh? We're excited, something's going to happen now. Or we're afraid something's going to happen. For example, my adrenaline is pumping because I'm writing an exam. My adrenaline is pumping because I'm going to see, what's that guy's name again? That
Jaden Smith and Will Smith.
There we go, Jaden Smith and Will Smith, or Justin Bieber.
Or Justin Bieber.
Justin Bieber, or whoever else that, I would have said something funny, but never mind, let's keep that's not for this show. That excites you, let's stick to excites you. Okay, Kaleko, don't read my mind, it's not a good
I'm
thing,
trying not to.
Do not read my mind. So now this is why I'm saying all these things. I just want to waste time, kill time so that the show gets over. No, guys. What I'm saying is some of these things, you don't have to memorize them. You don't have to learn them off. When I'm using these terms to tell you, think about when you're saying my adrenaline is pumping. What are you saying? What's happening in your body at that time? Huh? That's what's happening. First of all, your heart beats faster. Huh? When your girlfriend is telling you, I can hear your heartbeat. Right?
Yes.
I don't think I should be in the music industry. Right? Okay. If your heart beats faster, it's going to obviously increase the blood pressure. If you open a tap more water comes out. The heart is the one that's pushing the blood, is creating the pressure in the blood vessels. So if the heart is beating faster, the pressure will be more intensified. So increase. Those two go without saying. They follow each other. It also speeds up the conversion from glycogen to glucose. Glycogen is a stored form of glucose. You learned this in nutrition in grade 11. If you are excited, if you are afraid, if you need to act, you need energy. So therefore, you need glucose. So glycogen is being converted to glucose to give you energy. It causes the pupils to dilate, pupils of the eye to dilate. And when that happens, more light enters the eye, and therefore you can see more clearly, so you can deal with an emergency. Increases the blood supply to the cardiac and skeletal muscles. Cardiac, the muscle of the heart itself. Skeletal, the muscles of the skeleton. Why do you think it does this? Remember, this hormone is called the flight or fight hormone. So you're either going to run away or you're going to stand and you're going to fight. So your heart needs to beat faster because you need to rotate that oxygen and carbon dioxide quicker in the body and nutrients. And your skeletal muscle definitely need more oxygen because if you're going to run like hell. You need energy, so therefore you need that to happen there. It also increases the skeletal muscle tone. The condition of the muscles are in a good condition, ready for action. Increases the rate and depth of breathing. It's no sense increasing the rate of the heartbeat to circulate oxygen and carbon dioxide, but you're not getting rid of this carbon dioxide and you're not getting in fresh oxygen. So you start breathing. And these are things you can remember. If you're excited, don't you breathe deeper? You can actually hear your breathing at that time, yes? when you're scared, or when you're excited. Both scenarios, same reaction. Okay? If you imagine you in a classroom and they announce, Aslam Khan, report to the office immediately. Already you're thinking, why am I being called to the office? And some of these things start happening to you. Causes the blood vessels of the digestive system and the skin to constrict. Let's look at these two in conjunction with each other. At a time of an emergency, do we need to digest food, Katlecho?
No, we don't.
Not at all, right? And we do not need blood to go to the skin either, because these are not considered to be vital organs. Whereas the heart and the skeletal muscles are considered to be vital organs for an emergency. So therefore, more blood goes to the heart, and I may add, to the brain. Why the brain, you ask? Because you need to think about what you're doing. You need to respond, not react, but you need to respond. And to respond, you need to think, because you can well do the wrong thing in an emergency, and then you are screwed. Good. The next hormone there then is aldosterone. Aldosterone regulates the amount of salts in the blood. If there's too much of salt, aldosterone is secreted, so we can reabsorb the salt. If there's too little, less aldosterone, so we won't reabsorb, we leave the salt there. And it works with ADH, salt and water together, to bring about the salt-water balance in the body. There we come to the islets of Langerhans in the pancreas. First up hormone is insulin. And in one sentence, we say insulin controls or reduces the blood sugar level. Reduces the blood sugar level. Okay? How? Either it converts glucose into glycogen and fat in the liver, or it promotes the absorption of glucose to be used by the cells. I think we'll give you a small break.
I think you deserve a small break. So guys, during this break, download your notes on www.learnextra.co.za/live, and also check out the After Earth site, guys. That is www.lifeafterearthscience.com. Check it out and see what we'll be going through at the end of this segment, but at the beginning of a really, really awesome one. See you right after the short break. Welcome back, Mindsetters. Because you are grade 12s and you are really, really awesome. Don't tell the other ones that I told you. I'm kidding. Because you're really awesome. Saturday school, guys. This Saturday from 9 to 12:30, you can join us for all your subjects. Saturday school, they're going to be an hour and a half each, guys. So from 9 o'clock, get your books, your pens, anything that you may need, and literally park in front of that TV just to watch Learn Extra Live Saturday school. I know that it helps you guys a lot, and many of you have said that, wow, Saturday school is actually the reason why I passed prelims or June exams or whatever you're doing. So please, guys, tune in for that. It's really, really important, and you have a chance to do extremely, extremely well. So make sure that you pop over to Saturday school on Saturday, same time, no, not same time, same place as you're on now, channel 319, and at 9 o'clock to 12:30. Okay, sharp. Over to you, Aslam.
Thank you, darling. Let's move on, guys. We were talking about insulin. Let's go back first, because we stopped halfway. Let's go back. We're talking about the pancreas, the islets of Langerhans, secrete insulin. Okay. If you want to be technical, you say the beta cells of the islets of Langerhans secrete insulin. You do not need to require, you don't need to know that for the syllabus. But if somebody tells you that and you say, but I said something different, that's what's happening there. Insulin reduces the blood sugar level. Keep that in your head first. Then you have to explain, how does it do that? How does it do that? It converts glucose into glycogen and fat. Why? Because these two guys are insoluble in water. And if they're insoluble in water, they cannot be used. So they stay there. Okay? And at the same time, it can promote the absorption of glucose from the blood into the cells. So there was so much of glucose in the blood, we absorbing it into the cells, and once we take it into the cells, then obviously the blood sugar level will come down. And at the same time, it can increase the use of glucose by the liver and by muscles, thereby decreasing the amount of sugar that is in the body, or glucose. Glucagon, on the other hand, please, 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 and please, and please, and please again. Do not make a spelling mistake between glucagon and glycogen. Glycogen is the stored form of a carbohydrate. It's a polysaccharide, a huge carbohydrate. And glucagon is the hormone. So do not get these two mixed up. So what does glucagon do? It does the opposite to insulin. Where insulin drops the sugar level or the glucose level, glucagon takes it up. How does it do that? By converting stored glycogen from the liver or muscles into glucose. So there was less glucose, now there'll be more glucose. This is going to happen when you need glucose. In other words, for example, if you're sleeping, you haven't been eating, you get up in the morning, glucagon is probably doing the job to get your glucose level up because you haven't been eating. Or somebody that is fasting. They're not eating the whole day, so their glucose levels will be down naturally. And therefore, glucagon kicks in to take their sugar levels to where it must be. Still busy with that, the ovary. We're not going to go into the structure of the ovary because it's done in detail in reproduction. The ovary deals with two hormones, estrogen and progesterone. Estrogen gives rise to secondary sexual characteristics in girls or in females. And those are, example, development of the breast, they're getting larger, softer skin, softer, supple skin, if you want to call it that, feminine voice, and pubic hair, okay? And more importantly, later on, when this female is sexually mature, the estrogen every month prepares the uterus for possible pregnancy. So it thickens the lining of the uterus. By the way, that lining is called the endometrium. So every month, the estrogen is doing that. And progesterone, also by the ovary, but from another part, the corpus luteum secretes progesterone, also helps in further thickening the lining of the uterus and also maintaining pregnancy. So that means this level of progesterone will remain high if the woman is pregnant. If the woman does not fall pregnant in that cycle, then the level of progesterone will decrease and menstruation will follow. Again, more of that when we do reproduction. This is enough just to whet your appetite on that interesting topic that we're going to get to sooner or later. The testis, structure of the testis, again you'll do in reproduction. So we're just looking at it now, where it is situated, etc. And the scrotum outside the boy's body, the male's body. The hormone that comes from the testis is known as the testosterone. Testosterone, just like estrogen gave secondary sexual characteristics in females, testosterone gives secondary sexual characteristics in males. Example, the breaking of the voice, the deepening of the voice, and more body hair, pubic hair, underarms, facial hair, mustache, all those things there will be stimulated by more testosterone. Also, the development of muscles to make boys have so-called broader shoulders, etc. Obviously, do not confuse that with people that go to the gym, and that we talk of the natural situation here as well. I'm hoping we are together on the same page. That brings us to the end of the name of the gland, the name of the hormone, and the functions of those hormones. Remember, you need to know hypothalamus and ADH, the pituitary gland with growth hormone, FSH, etc. Go further to the thyroid gland, only thyroxine. Further down, the adrenal glands, adrenaline and aldosterone. Further forward, the pancreas, islets of Langerhans, insulin, and glucagon. Further down, the ovaries in females, and we're looking at estrogen and progesterone only. Further, in males, the testes, and we are looking at testosterone. Now remember, the reproductive hormones, you're going to learn in more detail when you do reproduction. Does it mean, Katlecho, that they have to learn it twice?
They can just learn it all together, right?
You learn it once, isn't it?
Exactly.
The function of testosterone,
yes.
whether you discuss it, I don't want to use the word whether you do it in reproduction or whether you discuss it in reproduction or you discuss it in endocrine system,
Yes,
it won't change.
same
Yes?
thing,
So
yes.
you learn it once, guys. Don't think that you have to learn it twice, and they are different concepts altogether. So once you learn it, you can use it on in both topics to answer questions on both topics. Very good, guys. Now we are moving on to what we call a negative feedback mechanism. And this mechanism is important in endocrine system because and in life, we need feedback, isn't it? We definitely need feedback in everything we do. Whatever we're doing, we need feedback. Like we're waiting for your feedback here. Is it going well? Are you enjoying what we're talking about? We want to know this all the time. Am I looking good today? Is Katlego looking good today? Not now on the show, but you'll tell us one day when you meet us, right? Okay, so everybody wants to know, did I do this? Did I do it well? Or whatever. Feedback. Now, the endocrine system functions on this feedback mechanism because the one triggers the other, and so the system runs. What is this negative feedback that we are talking about? It's a process whereby the response by the effector is opposite to and generally reverses the stimulus. Whatever the stimulus was, for example, if sugar levels were high, the effector is coming from the hormone that brings about the response is insulin. And where does it happen? In the liver. What happens in the liver? Insulin lowers the sugar level. So what was the stimulus? High sugar. What was the response? Lower sugar. Why? Because we want the sugar level to come back to normal. And that's important then. We want to show that, like we said in our story there, we want to show the interaction between the pituitary gland and thyroid gland as an example of this negative feedback. If, for example, this is the normal. You know what is the seesaw, Katlego?
Yes, I do.
You played on a seesaw?
Yes, I have, yeah.
You didn't play with a very...
With a very, no, I think someone
Because
might.
you know what they can do to you?
Yeah, I can.
They can keep you up there and they can just jump
and
off
then you just jump
you
off.
can crash off it. Right. So here's a seesaw here that we are talking about. If this is the level of where thyroxine should be, and if for some reason the thyroxine level increase above normal, this is normal, so it rises above normal, above this level. Immediately the pituitary gland is sensitized. So the control center is the pituitary gland. The stimulus is an increase in thyroxine. So the pituitary gland, the control center, picks up this stimulus and it sends out a response. The response is it either does not secrete TSH, no thyroid stimulating hormone, or less thyroid stimulating hormone. So therefore the thyroid gland is not stimulated. And if the thyroid gland is not stimulated, it will not release thyroxine. And obviously, if it does not release thyroxine, the levels of thyroxine decrease to normal. Stimulus, high. Response, decrease to normal. Negative feedback. On the other end of the spectrum, if for some reason the thyroxine levels decrease below the norm, the norm is in purple here, then what will happen? This stimulus is picked up by the pituitary gland. The control center does not change. What does the control center do? It secretes more TSH. And if it secretes more TSH, it stimulates the thyroid gland to release thyroxine. I would say still more thyroxine. And if more thyroxine is released, the thyroxine level rises back to normal. And this, in a nutshell, is what a negative feedback mechanism is all about. High, lower. Low, higher. Back to normal. So think of that seesaw every time you think of a negative feedback mechanism. Now that we have covered that part, let's look at the questions and see if we can answer the questions. First question says, study the diagram below and answer the questions that follow. First question, as usual in a question, is label the parts numbered 1 to 4. Number 1, pituitary gland. Number 2, thyroid gland. Number 3, pancreas. And if you want to be more correct, we'll say the islets of Langerhans of the pancreas. And number 4 would be the adrenal gland. Remember, the gland is called adrenal gland, and the hormone is adrenaline. So we've done that. Write down only the number of the gland. That. Now notice the instruction. Only the number. If you write the name, sorry guys, no marks for you. Only numbers. Produces the hormone glucagon. That would be the pancreas, but we don't want to say pancreas, we say number 4. The produces the hormone that controls the growth of long bones. Long bones would be the pituitary gland, and that will be number 1. Produces an iodine-containing hormone, that will be the thyroid gland, and that's number 2. Produces a hormone that is involved in the reabsorption of some salts by the kidney, that would be the adrenal gland, and that is number 4. Tabulate 3 differences between the nervous system and the endocrine system. Remember, we studied the nervous system before this. Now we must be able to differentiate between them. There we go. Nervous system, message is carried by neurons. Endocrine, by hormones in the blood. Nervous system, information is transmitted in the form of nerve impulses. Here, in the form of chemical messengers or hormones. This one, information travels very quickly. Here it travels slower, it's in the blood. Along nerve fibers in the blood, as we spoke earlier. Specific effects on effectors, that means immediately, you know, your eyes, your pupil dilate or they constrict, etc., etc., etc. Whereas in the case of hormones, there's a wide effect. It's not just a one specific effect on a particular organ. The effect of the nerve impulse does not last for very long. It's short term. It happens now and it's finished. Whereas with the hormone, it can last for your whole life, growth and development. Throughout your life, you're growing and developing, etc. Next one says, explain the mechanism between gland 1 and 2 when the metabolic rate is low. 1 and 2 is the pituitary and the thyroid gland. But they were specific here. They're not talking about anything. They're talking about when the metabolic rate is low. How do you answer that? First of all, when the thyroxine concentration in the blood decreases, that's what we're saying, below the norm, pituitary gland is stimulated to secrete more. I'll do that again. Go down and open. All right? So the pituitary gland is secreted to stimulate more TSH, and TSH stimulates the thyroid gland to secrete more thyroxine, and therefore increases the level of thyroxine in the blood to normal. Negative feedback. I love this one. You hear what this guy is telling his friend there? Okay, Katlego. See what he's telling his wife?
Yes.
Okay, so maybe it wasn't such a good idea to buy your estrogen pills off the internet after all.
So that's what happened to her.
What
after
happened to her, yeah. Now, let's look at very quickly. We don't have much time, but we look at the disorder. First one is endemic goiter, because if there's lack of iodine. It's a simple goiter. It's a swelling in the neck. You've got to increase your iodine intake. Hypothyroidism, where the thyroid produces too little thyroxine. Low metabolic rate, children cretinism, and all those symptoms. You can see the stuff on the notes. And what do? We give them medication. Hyperthyroidism, too much thyroxine, high metabolic rate. Remember, you must relate the disorder to the function of that hormone. If there's too much of that hormone, that function will be accentuated. If there's too little of the hormone, that function would be decreased. So that's what you have to do there. And we can talk about growth hormones, and you get gigantism, dwarfism, acromegaly, and then diabetes mellitus is the last one. One is where there's not enough insulin, and the other one is when insulin is not doing what it's supposed to do with the organs. And what must we do? Medication, insulin, or more importantly, what's your diet? When you're diabetic, what's your diet, and exercise as much as you can so that you can keep your metabolic, your glucose level to the right level.
Cheers, guys. Have a great evening.
Bye. As an example, remember in the examination, you can get any example. They can ask you to explain any example. Most of the endocrine glands secrete hormones that operate on the negative feedback mechanism. We can talk about ADH and water. We can talk about glucose and sugar. We can talk about glucagon and sugar. We can go on with all the hormones, estrogen and progesterone and FSH. We can look at that as well as a negative feedback mechanism. So you must be able to understand the principle and apply this principle to all the other hormones that we look at. Keep that in mind. Lastly, we also look at the causes, prevention, symptoms, and management of each of the following: diabetes, thyroid disorders, and growth disorders. Obviously, when we look at these disorders, we are looking at those disorders in terms of the endocrine system, not other disorders that cause some of these things. We're only talking about these disorders in terms of what we are studying. And what is that? The endocrine system. Good. Let's get right into it. As we've been accustomed, we mix and match. We put the questions in and look at the pituitary gland, growth hormone, TSH, FSH, LH, prolactin. And notice I'm going through the names quickly because we're going to look at them again. Thyroid glands and thyroxine, adrenal glands, adrenaline and aldosterone, the pancreatic islets of Langerhans, or the islets of Langerhans of the pancreas. We look at these two main guys, insulin and glucagon. Then we go into the ovary. That's not a nice thing to say, go into the ovary, but nonetheless, we look at the ovary. That also won't come out right.
Yes,
okay. So examine, that also won't be right. There's not many verbs that we can use in ovary. Nonetheless, we study the hormones that are secreted by the ovary, and they are estrogen and progesterone. And then we move on to the testes, and we look at the effects of testosterone in the human male, okay? So those are the things we're looking. Then we further go, we look at all of these glands, and we look at how they work, their hormones they secrete, and the functions of the hormones. Then we want to know, how do these hormones interact with each other? How do they control each other? And that's when this principle of negative feedback mechanism comes in. Although in this lesson, we use TSH and thyroxine.
Hello guys, welcome to Learn Extra Love Grade 12s. It's finally your turn. Today we're doing life science with Aslam. Guys, I'm so happy to be here. So happy to see you, Aslam. How are you?
What shall I call you? Shall I call you a mutant name or your normal name?
Let's call me my normal name.
Normal name. How are you doing?
Great, thanks.
Great to have you back.
Great to be here, actually. What are we doing today, Aslam?
We're doing some interesting stuff. We're looking at the endocrine system.
Okay.
And we're talking about hormones.
Awesome.
And what they do to
stuff,
you.
Eh? That's awesome stuff. So you guys heard that, a very, very important section. So I hope that you guys are watching, and I hope even more that you guys are going to be watching until 7:30. Yes, you heard me right. Today's show will be extended between 7 and 7:30. We are going to have the After Earth special, guys. Did you guys hear correctly? This is not just for you grade 12s. Of course, you grade 12s, by default, you're here. But this is also for grade 10s and 11s and your brothers and your sisters and your donkeys and your chickens, everything and everyone that wants to listen up. You better join us between 7 and 7:30. We will be going through some After Earth lesson plans to show you how the movie, I hope it's making sense now, or it will make sense then at 7, of course, that the movie actually links to some awesome stuff that you will be learning during the show today. So for you guys right now, to find out more information, you need to go onto Life After Earth science.co.za. I will be posting it up on Facebook for you guys to check it out. Also, more importantly, or maybe not more importantly, but also we are going to be having a live stream, guys, to a Macmillan launch for their digital ebook, guys. This is going to be live. We're going to be chatting to the awesome folks over at Mindset. Thank you guys for sponsoring our awesome show today, but I can't wait to chat to you guys at between 7 and 7:30, of course. So guys, make sure that you join us. For now, jump onto the Facebook page, see everything that's been going on. It's been such an awesome afternoon, and into the evening. I'm glad that you guys are here, and you will log on to Facebook, facebook.com/learnextra, and Twitter to find out more about this lesson on the endocrine system, as well as the after earth stuff, guys. So jump on there right now. Okay, also check out your notes, they're already up. So enjoy your show. Over to you, Aslam.
Katleho, you said a lot there.
I know I said a lot, eh?
You know what? Just listening to what we have to do makes me tired. You know? Good. We never tired, yeah. Are we?
Never
Katleho?
tired,
We never
never.
tired. We're full of energy. If not, we'll get some Red Bull. Okay, guys, we are there with endocrine system. Let's move on. We've got a long way to go today. We've got lots of things to do. First up, though, is what we're doing now, and that's from now till 7 o'clock. We are going to concentrate on the endocrine system and questions and answers related to that. And later, we'll talk over the other stuff. What do we do here? First of all, we look at the characteristics of hormones. And guys, if you've been following our program as we've been going along, you'd know that we have touched on the characteristics of hormones when we discussed plant, and I say it in inverted commas, plant, in inverted commas, hormones. Okay, so we've spoken about it, but we're not going to take it for granted that you know it already. We're going to come back to it again. Explain the differences between the endocrine and exocrine glands. What are the differences between those two things? Then we look at the location and the functions of hormones produced by the following endocrine glands in the body. Hypothalamus, and we look at ADH.